Hi there, in this video I'm going to show you how you can increase the speed of the configuration of sequences of DeltaV. Not only the ones of unit phases, which you see here, but also the ones of equipment modules. Unit phases exist of 4 or 5 pieces of sequential logic. The running logic, but also the exception logics. The only one that is not sequential logic is the failure monitor. Now running logic, or the other logic, consists of steps, transitions, and actions in this step. Maybe you already found out that the programming of these sequences is very, very time consuming. I expect in a normal batch project that almost 50% of the work goes into the programming of these pieces of logic, and that includes also the control modules. So that's a big amount of work. What you also always need to do is you need to divide this work over separate engineers. They always have a little slightly different way of working, so you don't get a uniform way of how these sequences are programmed. You also need a lot of information from other services. For instance, production or process engineers. They will help you how these phases will work. But of course they don't have the experience with DeltaV to create the code that is necessary to drive the valves and to start the pumps. So what I've created here is I've created a very easy way to make some kind of pseudocode. This code can be typed in by anyone, production, process engineers, and it automatically generates the script or the syntax for these DeltaV phases. So these phases which you see already here are already created. Assume that I want to create a completely new phase. I'm not going to do it here, not yet already, because this environment is not accessible for other services. So I'm going to use a very simple tool that everyone knows, and that's Microsoft Excel. Everyone which is involved in engineering of a project does have Microsoft Excel. It's very easy. You see there's not much information on it yet, because this is a template of an Excel of a new phase we're going to create together. You see here several sheets. For each logic we have a separate sheet, this story, and 2 other ones which I'm going to explain to you later. Now, if you have a small look at the columns, you see it's very repetitive. So you see the step description, terminal transition, and then it's all coming back in the next steps. So actually what we have to explain to the ones who have to fill in this Excel sheet is just the meaning of those 2 columns. And in the column step description, we ask the specifier or the project engineer to fill in a brief description for each individual step of its sequence. And he can make steps sequential, or he can make branches. I'm going to explain you later. So let's say that the first step in my phase is called init. Second is acquiring of devices. Then I'm running out of ideas, so I'm going to write some small text which does not say anything. But, let's say step 3, and then up to step 20. Now I've just created a very small, a 20-step sequence, and in the last one I'm going to write a little X here, which just means this is after this step you can leave the sequence can go to its complete state. This is just a normal sequence. Usually you also have some side steps, some branches, and I can fill them over here. Let's say that after step 5 I have the option between step 6 and step 6b, for instance, or even a third one if I want to. And after step 6 I'm going back to step 7. And after step 11 I have the option between step 12 and step 12b. But if the actions of step 12b were executed, my phase can also go to complete. So it doesn't have to go back to step 13 in this case. Okay. So I've now created a 23-step sequence in, let's say, 2 minutes. That's very fast. Okay, the sequence is already something, but a sequence is nothing without its actions. The whole meaning of a sequence is driving equipment modules or control modules with its actions. So I can also fill them in over here. In a text that is readable or writable for anyone. How am I going to do that? You see here that between column B and column H there are some hidden columns. I'm going to make them visible right now. Okay. And here I can fill in the actions of a step. Assume that I want to add some actions to step 4. Let's say 2 actions. And I just add 2 extra rows to the Excel sheet. And in this action I can write in a text which says what this action does. And I have the option to choose from different ones. Now this is configurable also for everyone. You see the list that you see over here comes from a separate sheet, worksheet, with the name syntax. And here you have a unique name. And this unique name here is actually the representation of some DeltaV code which is given in once by the automation engineer. So of course you can add actions, and you can modify them if you choose to use other libraries for control modules. So that's up to you, whatever you fill in. Okay, so assume that in step 4 I want to open a valve. Let's assume that I make a typing error right now. It's going to warn me, say, okay, this is not good. It should be something I would recognize. So if I type it right, no problem. Open valve, okay, which valve should I open? Well, I can fill in here a tag name, or I can also fill in an alias name here. Assume that now I'm going to fill in an alias name. Okay, I'm finished. So I know that in step 4 I'm going to open the inlet valve of my phase. Let's say that I'm also going to drive a PID controller or send a set point. Okay. To which one? Now in this case I'm going to write a real tag name just to show you that it's also possible. Okay. Yeah, but I'm not finished yet, because okay, which set point do I want to send? So I can fill in here a hard-coded value. This is what I call an argument. So this is an extra value, a variable that is part of the action. I can fill in here a hard-coded value, not often used, but I can also fill in here a reference to a batch parameter I've created. Assume that I've created in my phase a batch parameter with the name batch parameter 1. Okay, then now I know that the value of batch parameter 1 will be sent to the set point of PID 001 TC001. Okay. Second action is actually complete. You see, this is readable. Everyone can read this text. Of course, I can also add actions in the other branches. You see here also the possibility of the action configurator is visible. And I'm finished. So my entire phase is now configured. Of course, usually all the other steps also have some actions in there. But now I want to fill in all this data, which I've filled in this Excel sheet, and I want to transfer it to DeltaV. How does this work? Assume that I just make an empty phase. So what the tool asks is to start from a template. Why? Because usually your failure monitor is class-based. You want to tune up the logic, you want to add some extra functionality. So then you start with a template. But in this case, I want to show you that it's even not necessary. So I can start from a completely new phase class, nothing in it. That's not a good name. Open it. You see there's nothing in there. Nothing. This is all standard. You see here, no actions, no descriptions, nothing. This is just standard and empty. Now what I need to do is I need to make an export of this template, even if it's empty, and I put it in a folder. Going back to my Excel sheet, and at the bottom of my Excel sheet there is the button Make Logic. Press the button Make Logic, and I make a reference to this template I've just created. What this Excel sheet now will do is he will make a second file. Let me to show you. So there's a second file, test phase 2. The difference between those files is that the second one now contains the data of the Excel sheet. And the only thing I still need to do is import it into the database. And my phase that I've just created is there. You see? So for each individual step, he created a number according to a convention. He also added the description that I made in the Excel sheet. This description can be visualized for the operator, but this is another video I will show you later on. He made also a transition with a default expression in it. And also automatically he generated an action that writes the step index. And in the action in which I made the two actions, the real actions are configured. Actions, description, again, this can also be visualized in the next video, and also the confirmation. You see already that this is built up in a very standard way. So you see that this is done by a computer. All the steps are ordered in a very logical way. And this phase is now for 80% finished. So instead of building a phase in a working day, you can build it now in a 1 hour, something like that. And it looks even better. You see? It's that easy.